When you look at a scientific paper or a data set, or even just a photo, what you're really seeing is just a single moment in time. It's a snapshot, a super valuable one for sure, but still just a snapshot. So, what if we could take that static picture and just hit play? What if we could see the entire story unfold? Explore what happened right before, what might happen next, and see how tiny little changes could lead to a totally different outcome. And that's really the core challenge, right? A single observation gives us this flat, 2D picture. And while it's incredibly useful, it just can't show us the dynamic, living dance of an interaction. It can't show us all the what ifs. Okay, so let's dive into this, because this is where it gets really cool. Researchers are starting to use a brand new kind of tool to solve this exact problem. It's a reproducibility simulator, which basically turns a boring, static paper into an interactive digital laboratory. The tech that makes this all possible is called an agent-based model. Now, that might sound complicated, but stick with me. It's actually pretty simple. Think of it like creating little digital puppets, or agents, one for the human and one for the dog. Each one has its own feelings and behaviors, and the model simulates how they influence each other. It's a perfect way to capture that two-way street of an interaction. So the most important thing to get here is that this is not just a video replay. Not at all. It is way more like a choose-your-own-adventure book, but for science. You actually get to change the rules of the world and see how a completely different story plays out. And that's exactly what we're about to do. All right, so to build this little digital world, first you need a recipe. You need a set of rules and ingredients that are going to decide how our digital human and our digital dog interact with each other. This particular model is built on 15 key parameters. You can think of these like control dials on a machine that you can turn up or down to change pretty much everything about the simulation. We won't go through all 15, don't worry, but let's check out a few of the most interesting ones. Okay, so one of the coolest dials we can play with is the oxytocin rise rate. You've probably heard of oxytocin. It gets called the love hormone, and it's super important for social bonding. In this simulation, we can literally dial up or dial down how quickly that feeling of connection builds inside the dog. Another really fascinating one is called arousal coupling. This models how the excitement of the human can directly pump up the dog, and vice versa. It's that feedback loop we've all seen, where our emotions just seem to be contagious with our pets. And this is just brilliant. The model takes that abstract idea of arousal and connects it to something we can actually see, like how fast the dog's tail is wagging in the simulation. So the internal feeling creates an external action. So we have our digital characters, and we have our recipe of rules. Now comes the really fun part. We can start playing around with the possibilities and run all sorts of what-if scenarios. The process is actually pretty straightforward. You start with a baseline scenario that's set up to perfectly match the original study. Then you get to tweak those parameters we talked about, like petting intensity. Run the simulation and see what kind of brand new data it spits out. So, for example, we can compare two totally opposite situations. In one corner, a distant greeting. The human stays way back, zero physical contact. And in the other corner, high-intensity petting. We're talking up close, vigorous scratching. I mean, how different could the results really be? Well, in that high-intensity scenario, the simulation showed the dog's maximum oxytocin proxy could hit 1.0. That's the absolute top of the scale in this model. It literally maxed out. A massive bonding response. Now get ready for this. Contrast that with a distant greeting. In that simulation, the dog's maximum oxytocin only reached 0.0995. That's not even close. It's a staggering difference. And all of it was generated just by changing a few inputs in our digital lab. This kind of insight is the huge payoff. It's why a tool like this is a potential game changer. It gives us a whole new way to explore these complex dynamics. But, and it's a big but, with any powerful new tool, there's always an important catch. So, who actually benefits from this? Well, the list is pretty long. Animal behavior researchers can use it to dream up new ideas to test in the real world. Animal therapy practitioners can explore different ways to make their methods even better. And educators, they can teach this stuff without needing expensive real-world experiments. But before we get too carried away with all the possibilities, there is something absolutely crucial you need to understand about how this whole thing works. First off, this technology is in its early days. The creators themselves are really clear about this. They urge everyone who uses it to be critical, to check the results against the original scientific paper, and to think of this as a starting point for ideas, not a final answer. And second, and this is the big one, it's stated right there in the documentation, plain as day. And I'm going to quote it directly. The simulator, synthetic datasets, and this documentation were produced in whole or in part by an artificial intelligence system. Let's be really clear, this isn't real-world data. It's a simulation generated by AI. And that leaves us with a really fascinating question to think about. We've seen how this incredible tool can bring a static moment to life. But knowing that it's all AI-generated, what does a future filled with these kinds of digital labs really mean for scientific discovery itself?